and welcome to another video about the ATTiny, or in this case the ATTiny13A, which you can see just there, and a little LED pulsing away. Now this video, I'll say inspired by, but it got me thinking, was I watched a video entitled Tinkering with the ATTiny13 and a couple of related things. That was released on the pilofstuff's channel. I'll provide a link up there. Well, this has got me thinking when he mentioned about the brownout detector function. And that got me thinking about the other reset functions that the ATTiny13 and most controller chips have. They tend to have a power on reset flag, an external reset flag, a brownout detection flag if they have that function, and possibly a watchdog reset flag, so that you can understand what happened at the very beginning of your program, why you got there or how you got there. It's a kind of hint to the journey at the very start, and most of this is controlled by one register, which we should just look at. Now, this is just a reminder of what an ATTiny13 looks like. It's an 8-pin chip that has the power on pin 8, the ground on pin 4. It's got 5 general I/O ones, and this one here that can be reserved to provide a reset, and that's the function it's going to have today. And the register that we'll be interested in is down here on the block diagram. You'll see there is a register called MCU status, and it gets information from here, the timing and control. This is basically just a register with a set of 4 flags that are set or cleared at power up, and this is the register we should be looking at. Now what we can see here is the MCU status register and what its internals look like. Top 4 bits are reserved and will always read as zeros, and writing to them will have no effect. So the only ones that concern us are the bottom 4. As you can see, these are read writable, and those two have got a letter note associated with them. And it says here, we'll start from bit 3, the watchdog reset flag, which is set if a reset occurs. Now if this was set and it's just a standard power on, the power on reset will clear it down to a 0. Or if in later times you want to, you can write to it and clear it to a 0. And then we come to the next one in, which is the brownout flag. Again, this flag will be set if the voltage on the supply drops below the level set by the brownout reference, and this is in the configuration bit settings. And it says it's also cleared by the reset, power on reset, or by writing a 0 to that flag bit. Then we move on to bit 1, the external reset flag. Again, as its name says, if you have an external reset and power has not been removed, this bit will be set. If power has been removed and is reapplied, of course it will be cleared by the power on reset. And again, you can write a 0 to it in your software and clear it. And then finally bit 0, which is like kind of the important one, is this is a power on reset. This is the bit that you would normally see if your board is happy. You've just turned the power on, you read those flags and it says I've had a power on reset. So if you know that the power was good to go, then your program is good to go and you have no errors. Now there is a issue with the comment on here, a power on reset clearing the flag, which is technically correct but factually incorrect, because as you can see in note 1, the power on reset flag clears the brownout reset flag. But there's an issue with this. The brownout flag gets cleared by power on reset, but the flag is still active until the supply voltage gets above the level brownout voltage set point. So if you have brownout enabled, what will happen is you'll see two flags at power up. You know, we've powered on, we've got the brownout detection active, so the supply voltage is below the reference voltage, so the flag gets set at power as soon as power's on. When the power on reset flag goes active, at this point all the other flags should be cleared, so down here that should drop. But of course the supply voltage detection for the brownout flag is still telling the brownout system that the voltage is below the brownout reference level, so it stays. And so, you know, all the way up here, as it climbs, it still thinks it's seen a brownout condition, so the brownout flag stays set. So you should always read the power on reset first, because if power has just come up from nothing, that will always be set. But if the brownout detection system is running internally, you'll also see that flag. Look for that one first, and then you don't have to worry about that one. And in a true brownout, where the voltage drops and comes back up again, you will not see the power on reset flag. You'll only see the brownout flag. So it all works, but you just have to remember that instead of seeing a single flag on power up, if brownout detection is enabled, you will see two flags. Looking at the software, it's quite simple. We have a function called pulse. We have a variable called reg value or reg val. And the first thing we do when we get into main is we read the contents of the microcontroller user register, and we end it with OF because we're only interested in the bottom bit, even though the top bit should never be set anyway. And then we clear it, and then we set up the user port B. So we've got an output and some outputs and an input, and then we define. Actually, we can actually get rid of that, but then we define pin 4 as an input. We define it as having an internal pull-up resistor, and we define bit 0 of the port as an output. We won't worry about this here. This is just setting up the watchdog, and then we move on down here. And we go into a while loop. And in the while loop, the first thing we do is if the pin 4 is high, we reset the watchdog. If it's not, we don't do anything, we just fall through. And then we delay for a second, and then we test the register value. So if bit 0 is set, we have a power on reset, therefore we produce one pulse on LED. If the external reset flag is set, we send 2 pulses to the LED. And again, brownout flag set, we send 3 pulses. And if the watchdog, we send 4. And if there's a combination or something, if we've just fallen through because we haven't found one, it just sends 5. So if you see 5 pulses, you know that something went wrong. And then if we ever got to this point, we would exit the program. And then we come down to the pulse subfunction. It's basically a switch statement, and it's a fall through case. So you have a switch number. So if you get a pulse of 1, it falls down to 1. It sets the output high for 100 milliseconds, and it sets it low for 100 milliseconds, and then it falls out. What you might notice is if the number is set to a 2, it comes in on case 2. It sets it high for 100 milliseconds, sets it low for 100 milliseconds, but there's no break command. So it falls through into here, and it does it again. And this saves you having to have like 2 pulses in here, 1 pulse in here, 2 pulses in here, 3 pulses in here, etc. 4 and 5. So basically, if you want to send 4 pulses, it comes into 4 and it goes through 4, 3, 2, 1. So you get 4 pulses. It just saves a bit of code. This is quite handy when you're doing things like this, because it just reuses these statements and it saves you space. And that's all it does. So it's a very quick program just to display the contents at startup of the user register. Here we can see I'm about to turn on power. Power comes up and you can see the LED starts flashing once, indicating it was a power on reset. I'm now going to hit the reset pin, pull it low, external reset, and so now you should see 2. And up in the top right corner you'll see it slowed down a bit, just to show there is exactly 2 flashes. Next, brownout. I shall slowly reduce the supply to below the brownout threshold level and then bring it back up, and this should cause it to flash 3 times to indicate that it is browned out. And now you can see on the slow-mo on the top there are 3 distinct separate flashes. So brownout was detected as a means of method of reset. Now I'm going to short the input pin out, which will stop the watchdog being kicked, and then it should come out of reset and we should see 4. 1, 2, 3, 4, and then we have it. If you want to see more videos, hit the subscribe button, click that bell, and I'll catch you on the next one.